Hi, I'm Dr. De Bruin, and this is a quick walkthrough of how to answer an exam question from the equilibrium topic of AQA A Chemistry. We're starting off with some basic understanding. Can you give two features of a reaction that's in dynamic equilibrium? Well, firstly, we know that both the forward and the reverse reactions are going to be occurring, and more than that, they're going to be occurring at the same rate. Secondly, we know that all reactants and products are going to be present, and also their concentrations will be unchanging. Don't forget, this doesn't mean that they're the same as each other, just that they're not moving around. Next up, a reaction containing only gases is at equilibrium. When the pressure is decreased, the yield of the product decreases. What can you deduce about the chemical equation for this equilibrium? Well, we know that Le Chatelier's principle tells us that the system is going to shift to counteract the decrease in pressure. In other words, it's going to move to favour the side that has more molecules and thereby increase the pressure. And in this instance, if the yield of the product is decreasing, that tells us that the reverse reaction is being favoured and equilibrium is shifting to the left. So since we know that we have lowered the pressure and the equilibrium is going to try to raise the pressure, this tells us that the left-hand side of this equation must have more moles of gas than the right-hand side. Ethene and steam react to form ethanol. 0.23 moles of ethene is mixed with 0.66 moles of water in a container with a volume of 500 centimetres cubed. At equilibrium, the concentration of ethanol is 0.1 moles per decimetre cubed. So even though we're talking about gases, since this is a year 12 question, we're still thinking in terms of concentration and Kc. Calculate the amount in moles of ethene present at equilibrium. Well, in order to do this, I'm going to need to figure out how many moles of ethanol have been produced, because at the moment I don't have moles, I have concentration. So I know that concentration is moles divided by volume, and therefore moles is concentration times by volume. And my volume here is 500 centimetres cubed, but of course it needs to be in decimetres cubed. So I'm going to do 0.1 multiplied by 0.5 to get 0.05. Next, I'm going to look at my symbol equation to see what ratio the ethanol and the ethene are in. Well, actually here, this is very easy. They're in a 1-to-1 ratio. So for every 1 mole of ethanol that I make, I lose 1 mole of ethene. So my total moles at equilibrium are going to be the 0.23 that I started with minus the 0.05, which gives me 0.180 moles. Finally, I'm going to write an expression for Kc for this reaction. So as always, we're going to have our products on the top, and we're going to be using square brackets to denote concentration. And then beneath that, we have the products, and since there aren't any coefficients in the symbol equation, there aren't any powers in this expression. Thanks very much for watching, and I hope you're finding these exam walkthroughs useful. If there are particular topics you'd like me to cover, then let me know in the comments below. And don't forget to like and subscribe for more A-level chemistry videos coming soon.